All right, here's another one. By request, this one is from chapter 4.5. We're doing both number 9 and 16. Number 9 asks you to prove that this identity is true. So 1 minus 2 cos x equals sine x cos x bracket tangent x minus cotangent x. So I'm going in here a bit blind. Hopefully I'll be able to solve it in one shot, otherwise it'll be embarrassing. How would I approach this? Well, first off, dividing these sides to left side and right side, I'm going to tackle what I personally consider to be the most, I guess, convoluted, or something that I think might be easier to simplify. Okay, what you think and what I think might be different, but I'm just going to start there. A couple of things that I noticed. I noticed that on the left side there are two terms, and on the right side there is one gigantic term. But if I were to multiply this out, in other words, distributive property, I would get one term minus another term. In other words, I create two terms. So maybe it is in my best interest to actually multiply it out, because in my head it's easier to multiply than to factor back. So let's try it. On the right side, I am going to, another thing that I also notice is on the right side, I have tan and cotangent. It's just so much easier, in my opinion. Um, and I think it also creates more room for strategies if everything is written in terms of sine and cos. Again, that's my personal opinion, but that is a recommendation. That is um, I guess, a tip that I would like to pass on to you. You never know. Okay, so sine cos is going to multiply to both fractions. Noticing how the denominator is a cos, it will reduce. It will divide cos and cos on the numerator and denominator, leaving me with sine. You know what? Just in case people want to follow step by step and they don't quite understand what the heck is going on, I'm going to show the entire thing. This is what I mean. When sine cos is multiplied to sine over cos, notice that sine cos is technically a fraction over 1. So numerators are multiplied, sine cosine, and the denominator is just cos. Same thing here. Sine times cos is going to multiply with cos. So sine cos x cos x. I could have written as cos squared, I know, but I didn't for your purposes. There it is. And so I am going to reduce, leaving me with sine squared x minus cos squared x. Now we're getting somewhere. I have a sine squared on the right side, and that has to disappear somewhere. I am going to use my Pythagorean identity, because sine squared is equal to 1 minus cos squared, which gives me 1 minus 2 cos squared. Would you look at that? That is the same as left side. That is the end of my proof. All right, stopping there, I am going to clear to get to number 16. Number 16 gives you something different. It says to prove that sine 2x plus sine 2y. Oh, by the way, the person who has requested this video, honestly speaking, I see how sine number 16 could be a little confusing, but I'm surprised that you asked for number 9. I think maybe you've been working so hard that your brain's a little fried and you weren't able to see that solution. Because knowing your abilities, I'm pretty sure if you had a clear head, you'd have seen it easily. Okay, so maybe you do want to give yourself a bit of a break and calm your brain down. By break, I don't mean go and watch something on YouTube. I don't mean go play video games. I mean legitimately let your brain rest by doing either something physical, like a sport, or go for a jog, go for a walk, or I don't know, anything physical, or something legitimately relaxing, like sitting and just knocking your head back and closing your eyes for like 10 minutes. All right, where would I go from here? Actually, I think I might have to do both sides. Why do I say that? Um, It's a couple of reasons. One, this is a double angle, and I see that all the other angles are single. So maybe I need to break this down. I also see this is a compound angle formula on its way, and it's going to be a whole bunch of multiplications, and I feel like it might reduce itself. So yeah, I'm not sure which way is the best way. Um, I am going to start with this as the double angle formula. Okay, so sine 2x is like x plus x. So this is actually using an identity 2 sine x cos x, and this would be 2 sine y cos y. Okay, that's what left side is. The right side, oh boy, give me a second. Okay, where was I? Sorry, there was an interruption. Okay, so for the right side, 2, I am going to do compound angle. This would be, um, let's see, sine x cos, excuse me, cos y plus cos x sine y. And then cosine would be cos x cos y plus sine x sine y. Okay, there it is. And there's a lot more room for expanding. This would be sine cos. Oh boy. Okay, let's do this. I can do it. I'm going to need a lot more space because this is going to get really big. Here we go. Sine x cos y, cos x cos y, plus sine, oh, there's two cos, I don't know why I did that. I might as well just do cos squared y, plus sine x sine squared x, cos y sine y, and then multiply these two. This becomes cos squared x sine y cos y, and then sine x sine squared y cos x. Okay, looking at this, I see 2 sine cos squared y cos x, sine, no, so this is on its own. I'm going to do that. I'm going to reorder this. Sine x. Are they all different? Let's see, sine x cos x, sine x. Is there something I can simplify right away? I'm going to try something here. What I'm going to try is, seeing as how I only have 2 terms and all the squares are disappearing, I'm getting the feeling that I'm going to have some kind of cos and sine appear. In other words, I'm going to turn into a 1. So I'm going to make an effort to try that. So notice here I have sine x cos x. I have sine x cos x. I'm going to take this term and this term, and if I factor out a sine x cos x, I create cos squared y plus sine squared y from those 2 terms. Next, right? So I basically covered these 2 terms by factoring it. Please note, maybe instead of brackets here, I should have done square brackets. Okay, now these middle 2 terms, what do they have in common? They have a cos y and a sine y in common. So I am going to take out a sine y cos y, leaving me, so factor out a sine y cos y, leaving me a sine squared x plus cos squared x. So yeah, they both turn into 1 and 1. And since the 2 is there, this is 2 sine x cos x, and this is 2 sine y cos y, which happens to be, oops, cos y, which happens to be left side, and we have proved it. That was a bit of a tough one. It took me a little while to see what was happening because there are so many x's and y's with different ratios. I had to make sure that they were things in common. Again, the main thing that gave it away was in this quadrinomial, this polynomial, I saw a bunch of squares, and on the left side I saw none. So I'm going to assume the Pythagorean identity sort of reappeared somewhere here, made a cameo appearance. Hope that helps. Keep at it. Again, even for me, it's not that I knew what the solution was. It was just trying to see what could work, judging from what clues were given. Keep at it, and I hope I can answer some more questions for you. Uh, See you in the next one.